Okay, differential equations problem number 4. So we have dy over dx equals square root xy. And it's asking us to determine a region of the xy plane for which the given differential equation would have a unique solution whose graph passes through x0, y0 in the region. And that's what we're given here. So we're going to be using the existence and uniqueness theorem, which means we're going to have to take the partial derivative with respect to y of this function, which we can rewrite as xy to the 1/2, and then distribute through the 1/2, which is equal to x to the 1/2, y to the 1/2, or the square root x square root y. And since we're taking the partial derivative of y, we're only going to be worrying about this y term. Now, derivative of a square root is going to be equal to 1 over 2 of that square root. And since we're taking the partial derivative, then we carry the x through, right? So this is going to be the square root of x here, which means that the partial derivative with respect to y of this function here becomes square root x over 2 square root y. I don't know if that's the proper notation of that, but that's what it equals right here. So with this, all right, existence uniqueness theorem. So we see this y in the denominator here. So we know that this y cannot be 0, because then it would be dividing by 0. And x also cannot be 0, because that would give us, I think it would be undefined. However, right, if x and y are greater than 0, right, then this is a solution, and it's I guess it would be unique, but it exists, right? And also, because we have x here and y here, right? If x is less than 0 and y is less than 0, right? It has to both be the case. Then also it is unique because square root x over 2 square root y, right? If this is negative and this is negative, then that's equal to as if it were positive again. See? So there's a unique solution in any rectangular region where x is greater than 0 and y is greater than 0. I should say that this also is and. Or x is less than 0 and y is less than 0. So yeah, that is the solution to that problem.